Hello? Yeah, there we go. I found the microphone button. Look at that. Well, excellent. So, thanks for coming out towards the tail end of the week at any rate. So my name's Dan Illson. I am a cloud solution architect here at VMware. So my group works on all of our subscription and SaaS delivered software that has a native public cloud attachment point. So we are not the people who get asked a lot of vSphere questions. Sometimes we do, but we're not very helpful. Native public cloud to us, that's any of the hyperscalers plus Kubernetes as an endpoint, right? So we are in many ways the black sheep at times of the VMware family, but that's fine. I think some of us kind of like it. So what we're going to talk about this afternoon here is we're going to talk about a service that we have in our portfolio called Cloud PKS. It used to be called VMware Kubernetes Engine, and then we did some portfolio rebranding, rebalancing activities here recently, so it's now called Cloud PKS. It is a SaaS delivered Kubernetes cluster as a service offering, okay? There is no vSphere involved in the stack. There is nothing you would think of as a traditional VMware product with a V and a blue and green logo in front of it, right? It is built out of Kubernetes from source and community tools that we needed, plus some custom code to make it all go and allow us to offer a multi-region service. So we're going to look at that and then how we interconnect clusters in that environment back into our native AWS service endpoints, our RDSs, our S3s, our queuing, et cetera, so on and so forth, right? Okay, so because I represent a little bit of a different side of the product portfolio for a lot of people, the first thing I say is all of the stuff that my group represents you can find on cloud.vmware.com, right? And on there are categories of our different services. You can look at descriptions, pricing information, all the stuff you would expect from any reasonably modern cloud service in terms of upfront information is there, as well as links that you can click on to say, hey, I think this is something I might want to try. Here's my email address. You know, maybe have somebody reach out to me and tell me how I log into this stuff and get after it, okay? We have a console, which you'll see here in a little bit, looks a lot like you would expect from that perspective. And again, Cloud PKS, and again, in the recent rebranding activity, I apologize, we didn't quite get that one in the image, so it used to be called VKE, it's now Cloud PKS, same service, we just modeled the name slightly to align with a portfolio approach, okay? So, this is always interesting because I'm right in front of the slide and I can't ever tell if I'm blocking something critical, but you know, when you talk to VMware about Kubernetes specifically, right? It's actually number one, I get a lot of, wait, why do you guys care about Kubernetes? That doesn't seem like something you should do. I care a lot about services wrapped around workloads, so it turns out I have to care about Kubernetes now. But also, we look at it from a couple different perspectives. Instead of focusing so much on where you put it, I actually think our portfolio breaks down a little more along an operational line. So there's kind of two. There's the PKS product that has existed as a set of licensed, sold, customer managed software, predominantly on premises, but you can install it in some other environments as well. And again, that's where we ship you the bits, you get a license, you install it, you set it up, you run the life cycle of that whole enterprise, you know, turn all the knobs, pull all the levers. Very standard software delivery process for VMware. Cloud PKS represents the other side of that, where we say Cloud PKS is a SaaS delivered service, fully managed Kubernetes clusters. This is for the organization that comes to me and says, I really want to get involved in the Kubernetes side of things. I don't need to turn all the knobs. I don't need to pull all the levers, and frankly, I don't want to. I just want to get a cluster. I want to do what I need to do. Tends to be a hit among developer organizations, individual lines of business with an app that they need to get out, and maybe they want to run an end around an obstacle or a small boundary that they're encountering, stuff like that, right? These tend to be the groups that have more affinity to the latter model, but we get some big enterprises that have said to us also, we looked at this, we scoped out what we thought it would take for us, and frankly, we don't know that it's worth the time, energy, resources, et cetera. So let's look at a different approach, right? So that's how we segment them. Obviously, over time, we're going to extend the environments that these can attach, that both of these different offerings can attach to. So I wouldn't get hung up on environmental concerns. For me, it's more of an operational concern. You want to run it and deal with all of the ongoing care, feeding, customization yourself, or is that not important to you at a cluster infrastructure level? in that case, maybe Cloud PKS is a more apt choice. Okay? So at the core of what we do in Cloud PKS is what we call a smart cluster, right? So a smart cluster is a Kubernetes cluster. So it is a Kubernetes cluster as you would expect it from any other modern Kubernetes delivery method, plus some custom logic that we've added to help us do some things operationally. So for example, we have a cluster autoscaler that goes beyond what's out there in the community right now in terms of autoscaling worker nodes, but also autoscaling other resources, both in and out, attached to the cluster, right? Most of the community autoscaler implementations right now are out, but they don't come back in, right? If you give them a bunch of specs, they'll take it, they'll build worker nodes for you, but if you want to bring that cluster back down, constrain your cost and your footprint, they're not really going to look at that. So we break it down into two distinctions right now, and we may add kind of additional flavors to this over time, but right now we have a development cluster and a production cluster, okay? Development cluster is single master, single availability zone, not strictly isolated, right? When I say not strictly isolated, it may share a VPC with other clusters, okay? Production cluster, triple masters, triple availability zones, so one master per availability zone, worker spray also across multiple availability zones. So you've got some built-in redundancy and resiliency there, plus strict VPC isolation guaranteed. So if I want to do things like establish network connectivity out to a different domain, I now have an understandable and grokkable IP space to rationalize as I go to mess with my routing table and begin to do that, right? Going to be very important for the connections feature that I'm going to talk about in a minute, okay? So, that's how we break those down. Again, we may add some more flavors, but really the key here is community code cluster plus some custom logic that we put in, and probably some more things that we'll add in the future above and beyond our scaling algorithms. Okay? So this slide just lets us blow out the block diagram on the production cluster a little bit. Again, because of the feature I'm kind of talking about today, production cluster is going to be the one we're mainly interested in so that I can have that strict VPC isolation, as you'll see behind me, right? Again, multi-master, multi-AZ. We want that resiliency, we want that redundancy. But then beyond that, it's a pretty standard cluster implementation. You're going to have your master nodes, you're going to have a few namespaces by default. You're going to have whatever pods you put in there. If you look in a namespace that we put in called VKE system, that's where we put a lot of our default pods. You'll see things like Calico, you'll see things like kubedns, you'll see the basic bones you would need to make a cluster go, plus an ingress controller that we've had in there by default for some time. Although you can pick any other ingress solution you want and slap it in there. We put one in by default just so if somebody comes in and doesn't have a strong opinion yet, they have an easy path to do basic ingress. It's an Nginx controller, nothing particularly earth-shattering or out of left field. Okay. So, as we would expect from anybody building and offering a service that's rolling out Kubernetes clusters to the rest of the world, we have to give you good ways to talk to these things. So, in addition to the Kubernetes API, right, you're hitting the Kubernetes cluster API endpoint. In addition to that API, there's a service API, because if you think about it, we're sitting in a layer above where we're provisioning the clusters themselves and a hierarchy of objects above that, right? So we've kind of arranged some supercluster objects. We have a construct called folders. So clusters are a member of a project. Projects are a member of a folder. Folders for us are a member of an organization or a tenant. So, your company would potentially be a tenant. You could have folders under there divided by project team, divided by line of business, whatever makes sense. Projects divided by individual developer, specific function, whatever you have, right? So we do give you a fully RESTful API with a Swagger or Open API spec available to look at all of that. We also offer a CLI wrapper package. It's essentially just a wrapper around that API for some easy basic operations. I'd say the CLI package is 85 to 90% of what I use on a daily basis as I'm going about what I do. The API I kind of save for some broader scale automation things, but the quick and dirty is almost always through the CLI package. It's just a wrapper, so it's a complete mapping functionally of what's in the API section as well. Okay. So, the feature the feature where we actually take these clusters that we have our nice strict VPC isolation around, so we have a strict and defined network namespace that we can deal with. The feature we use to get out to other endpoints is something we call connections, right? Right now for us, connections in AWS is VPC Peering based, okay? So we use VPC Peering across Amazon's network to run that connectivity. We are looking at a couple of other options to kind of extend that feature to complement VPC Peering, because we have some customers for whom it's not the ideal mechanism necessarily. So a couple other things we're looking at are actually internal VPN termination, meaning VPN termination on the cluster itself, or within the cluster itself. So that'll be one option that would allow us to then terminate that VPN out to anywhere a customer wants to specify that is a compatible endpoint. It'll be IPsec. I mean, it'll be pretty standard IPsec level 3 VPN. And then the other one that we're trying to figure out how we want to address is private link, and actually being able to publish services from inside your Kubernetes cluster on Cloud PKS out via private link as an endpoint elsewhere. So those are things I think over the next couple months you'll start to see us probably put them out in a preview for a month or two and then roll them into the mainline service code. So those are things we'll do. But right now it is VPC peering based. So predominantly for the folks that want to avoid, internet gateway transit to a bunch of these services, particularly the data services, it's normally where we hear that most. It's like, oh, well, that's my S3, that's my RDS, that's my Dynamo, that's a data service for me. I don't want that transiting the IGW. I want that coming through private networking on the Amazon side. Right now we'll use VPC peering, and that's how we'll approach it, right? So for those services, the ones that have an in-VPC endpoint, obviously that becomes a lot cleaner. For the ones that don't, we've actually done some things where we run it out to a VPC, and then we've worked with the customer to run connectivity from their VPC securely out to those other endpoints that don't necessarily have a cleanly defined in VPC endpoint. There are a few still. Okay, so because we're riding on top of VPC peering as a construct, we do pick up some of the config limitations that come with VPC peering, right? So, for us, it's a layer 3 connectivity. Predominantly right now, we use it in an egress fashion relative to the cluster. So from the cluster sees it as an egress. The reason for this is because we don't want to yet open the door to be able to say anybody from the outside can connect into your cluster easily, right? So what we do right now is when you establish a session from your cluster out, we'll essentially allow transit back on that same connection. We'll open it up to that same endpoint. We're not going to open the door wide so that anybody can now come in and potentially have access to your services inside the cluster that may not be public as far as you're concerned, right? The guys in the engineering right now are actually working on a tuning mechanism that will allow me to whitelist a set of endpoint destinations and say, hey, even though I haven't specifically opened up a session to these 6 places, they're allowed, I know who they are, it's cool. Don't worry about it, right? So, and to do that, of course, we're controlling the security groups on the Cloud PKS cluster side to manipulate that ability. Because of the way DNS is set up right now, we'll support intra-region DNS resolution, but not inter-region yet. To do that, we're probably going to have to layer in a DNS component for our service to help with some of the resolutions there. It's going to take us a little bit more time. And we do get held to a limit of 50 connections per cluster. And again, that's literally the AWS VPC peers per VPC limitation. So nothing fancy or considering there. Again, anytime you use VPC peering, you have to be really careful about your IP space. Make sure you're not using privately addressable IP blocks that overlap with each other or can cause conflicts. We are manipulating the routing tables on our side to do this, routing certain subnets over the VPC peer, so, be very aware of that. We do call all that stuff out in the cluster information, so you know specifically what the networks involved in the cluster are from both a pod networking perspective as well as a node networking perspective, because you're going to need to know both. And you're going to have MTU size limitations across the peer. And again, that's Amazon's infrastructure, not anything that we put into place, so just be aware of that one. So the actual process where we build this out, again, we're running fully managed Kubernetes clusters here, and that means we're assuring not just the masters, but also the worker nodes. As a result, our customers don't have direct access to the VPC where the cluster sits from an Amazon console level, right? If we do that, to do that would essentially break the operational model of a fully managed cluster. So what we do is essentially from either the UI, the CLI, or the API, our customers essentially submit a request, and what they submit as a request is, here is the remote AWS account ID I want to connect to, here's the remote VPC ID I want to connect to, here's the VPC subnet inside that destination VPC and the region that it sits in. With that information, our backend system that's provisioning all of the clusters in these accounts takes that and issues a VPC peering request towards the specified destination, okay? You see that as a standard VPC peer request in your Amazon console. So once you've issued that in Cloud PKS, you're going to have to go in, however you access your Amazon console, either directly via the web or via, Boto, CLI, whatever it may be, and approve that connection. Because again, any VPC peer isn't active until it's been both requested and approved on the other side. Okay? Once that gets approved, our backend system provides the account ID and the account ID, region ID, VPC ID of the cluster VPC itself. Gets accepted, rejected, peering comes up, traffic starts to be able to flow over there. We adjust our security groups on our side to make sure that connections will flow between the two VPCs. The one piece after this that a customer might have to do is if you want any traffic flow back across that link, you'll have to adjust the routing table on your VPC's end. Okay, we can't, from our perspective, we don't yet have a way to manipulate that, and it's kind of been an operationally touchy issue with customers. Like, do you want us to do that? We could potentially do that over a role and a user, but that gets operationally complicated, and nobody's been sufficiently interested for us to go really spend time on that yet. So what we tell people is, look, we'll give you the node network that you need to land on the other side. You need to make sure that node network is routable over the VPC peer from your controlled VPC's route table. Okay? Otherwise, it's going to be a unidirectional connection because you're going to get black hole trying to come back unless you route that over the peer itself. Okay? And again, with our peering commands, you can do them by the UI, you can do them by the API. Okay? So, what I'm actually going to do here is the thing that makes everybody nice and nervous. Okay. Here we go. Now there's a decent chance I'm going to have to enter a two-factor code here. Yeah, and I am. So, apologies for just a moment. This is the fun part of doing these from conference Wi-Fi. There's always the multiple authentication challenges, right? But this is our console, right? So for anybody that's using any of our services, this is the console that you hit. I have a laundry list of services available to me, and a couple more down here that are not available to me in this account. So it is a console much like you would hopefully expect. From within here, we have mechanisms to get to all of our different services. Because I'm an owner and administrator of this organizational tenant, I have the ability to control IAM in here and invite new members, grant them access to services or restrict their permission on a service, and I have the ability to control our billing as well. Although internally it's basically funny money, so you guys will know how that goes. I'm going to go grab the Cloud PKS service here. It's going to redirect me into this specific service. And this is what I hit when I come into the service, right? Again, the purpose of this service is not to deliver everything you've ever wanted to do inside your Kubernetes cluster. It is to deliver you a way to build to easily and rapidly build Kubernetes clusters as a service. What you do with the cluster beyond that point is up to you. Okay? So first and foremost, I'm going to want to create a cluster. I've already built one. We're not going to go through the whole process, but it can be as simple here as 3 parameters. Pick a cluster flavor, pick a region, give it a name. From there, you can hit go, and depending on how quickly Amazon ELBs are resolving domain names today, you'll have a cluster somewhere between 3.5 and 4.5 minutes. Okay? Now, that cluster, when you bring it up, will have no attached worker nodes. It will just be the masters. The rationale for that goes back to the smart cluster thing we talked about up front. The idea here is we're not going to spend your money and provision resources for you that you don't need yet. Now, when you connect to that cluster via kubectl, via the API, via whatever you want to do, and you ask it to deploy something, when you try to schedule something against that cluster, the smart cluster logic kicks in and it says, well, hold on, you have no available resources. You've asked me to deploy something that I know takes up more resources than you have. I'm going to build and attach worker nodes to your cluster, and then I'm going to schedule that. Okay? Worker node build on an average day takes us 90 to 120 seconds. So it's shorter than it'll probably take you to go grab a cup of coffee from the kitchen next door, right? So once we do that, I'm going to pull up a cluster I built for this. So once we do that, here I've got a cluster that's got some things deployed in it, right? So within that, one of the things we'll see here is that I've gone and provisioned out to my personal Amazon account a connection network. And we can see that it's active in here. We can see, here's where I can actually see the details of the cluster account in VPC. But here's my peer account in VPC ID that I put in and specified, right? Now, I can tell from here that's in US West 2, and I can see the subnet that I specified for that cluster. This is now an active connection. Now, to show this off, I like to use my little demonstration app, which, because I find myself currently living in San Francisco, is a super hipster out smart unicycle because somebody on my team thinks they're funny. So, simple web front end that's running inside the cluster, simple sign-up form that's passing information back to a SQL database. In this case, it's actually RDS. It's RDS with a private endpoint, so I can kind of show off this functionality. And then I have a Flask API server in another container next to it that's actually running the, if this is the data push into the database, that's actually the data pull out and read out, right? So, today I will put myself in well, actually, before I do this, so that you guys believe me that I didn't totally rig it, let me go to one of my API servers here for this environment. And you can see right now in the database, sorry, it's a little small, but we've got the JSON readout. We've got one user in there. That's Sean, who thinks he's funny and likes unicycles. But I'll add myself. Okay? So that's running inside my cluster. That's taken that information, run it out through the VPC peer to the private RDS endpoint, stuck it into my RDS database, right? Now, if I run a refresh here on my Flask server that's going to do a poll in my database table, and look, hey, look, there I am, right? So, nice, easy way for us to do this on an easy, simple to set up cluster, and a nice, easy way for us to do it, access our own data services without transiting the IGW and doing anything particularly insecure or unsavory over the internet, because my security people get very angry when I do things like that. So, it's a simple feature, but it's a necessary one for the way we build and operate clusters and the services that our customers need to connect to. As I mentioned during this talk, we're going to go through some things here over the next few months to try to make it an even more flexible feature from a connections perspective, right? And so that we're not relying on just VPC peering as our only mechanic. We're going to have some other mechanics as well to give customers a little more granular control over how they do things. And then in the not too distant future, we'll get to some even more fun pieces as we layer on another service that we're working on internally right now. But I believe, I don't think I had any more slides actually in this talk, but let's look real quick just to be sure. No, I didn't. So I'll be around for a couple minutes, guys, while the next speaker spends up. I'm happy to answer any questions you might have, talk to you about it. If you'd like, there are cards here that have a code to actually try the Cloud Pkf Service. These codes, I believe, are eligible for $150 in promo credits right now. So the way we price stuff out, that should get you a couple clusters effectively for a couple months to play with. So if you'd like one, please come up and get one. Be happy to talk to you about it. Thanks for coming out today, everybody. Enjoy the rest of the conference. Have a safe trip home.